All right, we're picking up on 18, talking about factoring. So remember, factoring just means backwards foiling, right? We're pulling everything out. It's the opposite of multiplication. So what we're doing is we're looking at this and we're saying, okay, well, how could we break this down, right, so that it looks like this? And we talked about in class that we're just backwards foiling. So we know that first times first, right, it needs to give us x squared. And we know that that would work if we just put x and x. The last thing we need to figure out, or the next thing I guess, is the last times last. So we know that the two numbers that we put in these spots, right, have to multiply that last number. So we're saying what times what would give me a negative 36. And we just kind of listed the factors. So 1 times 36, one of those would have to be negative. Or it could be 2 times 18. Or it could be 3 times 12, or 4 times 9, or 6 times 6. So there's a whole list of them, and you guys had your little factor chart. Okay, and we know that they need to subtract to this middle number, so negative 5. So if you look at all these groups, it can't be 6 and 6, because that would subtract to 0. 9 and 4. So notice if I have 4 minus 9, that gives me that negative 5, that gives me that middle term. So that's like when we're foiling, right? That's the outside and the inside, and they are adding together to negative 9. So we actually know that it's going to be this right here. So we just put in a positive 4 and a negative 9, and this guy is the factored form of that polynomial. Again, just backwards foiling, right? None of these others would have worked if we tested them all out. That was the only one that worked there. Okay. Again, I'm going to jump and do one more similar to that before I jump into the others. So if you look at number 21, let's jump to 21. 21 says n squared plus 5n plus 6. So again, there's no greatest common factor that divides out of everything. So I'm going to start with just backwards foiling. I know that I'm ready to create these two pieces. I look at the first piece, and that would be n and n. Then I look at the last piece, and I list the factors of 6. So it would be 1 and 6, or 2 and 3. Now on this one, everything is positive, all of these positive signs. So we need something that adds to 5. So 1 plus 6, that's 7, that doesn't work, but 2 plus 3 adds to 5, so that one works. So we put in a positive 2, and we put in a positive 3. Okay. Again, multiplies to the last number, and in this one it's adding to the middle because it's positive. All right, let's look at number 19. So number 19, we look at this one and we say, okay, well, is there anything that divides out of everything? So we start with the greatest common factor. There's nothing common between 3 and negative 26 and negative 40. So this is one of those where there's a number out front. Now we learned two different methods in class. Some of you like the bottoms up, some of you like the factor by grouping. I'm going to do bottoms up first, and then I will do a factor by grouping for those of you that liked that better. So let's look at the bottoms up. Remember, in bottoms up, we take this front number that's kind of in our way and we multiply it to the back so that it looks like one of the others that we can factor. So that leaves us with n squared minus 26n minus, and we multiply that to the back. So if we times negative 40 by 3, we get negative 120. Oops, I forgot the n. Sorry. Notice this one just looks like the others that we did. Very similar. We know that when we start to factor this, right, to get the first piece, that's n and n. And then we need to look at the last piece, which is negative 120. So if I'm looking at things that multiply to negative 120, that could be like 12 and 10. One of them needs to be negative, right, because of this. It could be, let's see, what other factors of 126 and 20? Or 120, this is when I need you guys' calculator skills here. Guess I have to do it on my own. 4 and 30. And essentially you're just looking for ones, right, that have a difference of 26. So they need to subtract to 26. So notice on this one, if I subtract this anyway, I'm going to get 2 or negative 2 on that one. That one doesn't work. If I subtract this, these have a difference of 14. So I either get a positive 14 or a negative 14. But notice on this one, 4 minus 30 is negative 26. Hit the jackpot there. So we want a positive 4 and a negative 30. Now remember, we're not done on this one just because we multiplied that 3 to the back. So we need to divide that 3 back out. So we make sure that we divide the number we multiplied to the back out. Now 4 divided by 3 doesn't divide out nicely, so this is where we call this bottoms up. If there's something stuck in the bottom, we just move it to the front, so that's 3n plus 4 on that piece. The next one, it looks like we have n, and then negative 30 divided by 3 is just negative 10. So that right there is our factored form using the bottoms up method. So again, if you are more comfortable with this one, there's the bottoms up. Okay. Let's jump down and look at number 20. Now number 20, again, the first thing we always ask is there a greatest common factor? Well, if you look at this one, there definitely is, right? 8 and 20 can both be divided by 4. They also both have a v in common. So we could actually divide out 4 as well as a v. So remember, that means we're dividing it out of every term. So that right there would give us 2. And then if we have v squared divided by v, that leaves us just with a v there. The next term, 20 divided by 4 is 5, and then the v's cancel, so we just have plus 5. Now that's as far as you can go on that one. That is factored completely. Okay. All right, let's look at maybe number 23. So number 23, we're factoring out a greatest common factor. So notice all of these values are divisible by 5. So we're going to divide out of 5. And that leaves us with, I'm going to write it underneath so I remember that's what I'm dividing. It leaves us with n squared. Negative 25 divided by 5 is negative 5n. And 70 divided by 5 is negative 14. Now notice when you divided that 5 out, there's no more number in front of that n squared. So we like these ones because the 5 is still going to come along, but now we can just factor this trinomial right here, very similar to how we did the trinomials up here. So once there's not a number there, right, we're just factoring it. We know that this will be n and n. Then we look at this last number, factors of negative 14, and they need to subtract to 5 or have a difference of 5. So 2 and 7, right, would be the obvious choice there. And we want it to be a negative 5, so that means the bigger number needs to be negative. That works. So I want a positive 2 and a negative 7. That's as far as we go on that one. Okay. Now, sometimes you factor out a greatest common factor and it doesn't work out quite that nicely. So let's look at 24. On 24, we've got 21p squared plus 6p minus 27. All of these are divisible by 3. So let's divide them all by 3. 21 divided by 3 is 7. 6 divided by 3 is 2. And negative 27 divided by 3 is negative 9. So if we're looking at this one, notice there's a 7 here. So this is one of those where the 3 is still going to come along the whole time. Oh, that's not a 3. Remember we wrote that big 3. And then we just said, okay, now we're going to bottoms up here. So 7 times 9, we get p squared plus 2p. 7 times 9 is negative 63. So now we know that this is going to be p and p. Factors of negative 63 that need to have a difference of 2 because it's negative. So we're looking at 9 and 7. Excellent. We want it to be a positive 2, so we're going to do 9 minus 7 because that gives us the positive 2. So we're going to have a positive 9, a negative 7, and then just remember to finish bottoms up, you've got to divide back out whatever number you multiplied in. And it looks like we multiplied that 7 to the back, so we want to divide these by 7. Okay, so our final answer, again, we have that 3 out front. We then simplify 9/7, which doesn't simplify, so we move the bottom up. So 7p plus 9. And then lastly, we simplify this one. P minus, and 7 divided by 7 is just 1. So we're looking at this as our final answer. Okay. Number 25 looks a little weird, right? 9x squared minus 16. We look for something that divides out of everything. There's nothing there. This is one that we call the difference of squares. Okay. Now you can use the bottoms up on this. You're finding something that multiplies to 0 because there's no middle term. But really we talked about if you see that these both have nice square roots, both of these values, and it's a difference, meaning subtraction, then we just know that this will break apart using the square root. So the square root of 9x squared is 3x and 3x. That would multiply to give us 9x squared. 16 would be 4 and 4. And we know that 1 has to be positive and 1 negative, so that that middle term cancels out and is no longer there. So this one just a difference of squares. All right, if you were most comfortable with the bottoms up method, then you're good to go. Give this last one a shot. If you like the factor by grouping, I'm going to look at number 22 using factor by grouping. So again, the first thing we do is look for a greatest common factor. A 5 divides out of all of those. So we're going to pull a 5 out front, and we get 3b squared minus 4b minus 15. Again, the 5 is just with us till the end. We do need to make sure that in the end, right, we have that 5 out front. So don't lose that 5. On the inside, those of you that like to factor by grouping, this is how we did it, right? We just took this piece and we said, well, let's multiply it by this piece. And 3b squared times negative 15, probably should have wrote that a little different, is negative 45b squared. So then we said, okay, well, what multiplies to that but gives us the middle term? So again, it's very similar to how you do the bottoms up, but we would say like 9 and 5. So 9b times 5b, that gives us this middle term if the 9 is negative. So essentially we just said we're going to split this up into 4 terms like our factor by grouping. So we've still got the 3b squared out front. We then put in the negative 9b plus the 5b that we just created, and then minus 15. Notice that's the same thing as this trinomial right here, but we've split up that middle term in 2 pieces. That allows us to group. So we group these two, and it looks like they have a common factor of 3 and a b. These two here have a common factor. They're both divisible by 5. So on this first one, we've essentially pulling out a 3b. It looks like 36. It's a b. So the 3's go away on that first term, leaving a b. And then negative 9 divided by 3 is minus, or a negative 3 there. And the b's cancel. On this second piece, we've got that 5 that's going to come out front. And that leaves us with a b for that first piece. And if we divide this, negative 15 divided by 5 is negative 3. Notice now you've got that b minus 3 and that b minus 3. So essentially we'd have b minus 3. And then the leftover goes in the second one, 3b plus 5. Now again, you'll get the same result if you use the bottoms up method. Just using whichever one is most comfortable for you. Okay, that's factoring. You are going to see some of